In November 1944, a U.S. Navy fleet submarine limped into Norwegian waters after sustaining damage during a patrol in the North Atlantic, its crew attempting to reach a neutral port for internment rather than surrender to German forces. Mechanical failure forced an emergency surfacing in a fjord controlled by German naval forces, and within hours the USS Barbara ATO-class fleet submarine with capabilities that would astound its captors was in German hands. Within 2 weeks, Kriegsmarine submarine commanders were sailing an enemy vessel that represented everything German U-boat design was not: spacious, comfortable, reliable, and equipped with a range exceeding 11,000 miles that enabled operations German submariners could only dream of achieving. What they discovered would force a reckoning with uncomfortable truths about why Germany's U-boat campaign was failing, not because German submariners lacked courage or skill, but because American industrial philosophy had built submarines optimized for a different kind of war, in a different ocean, with crew endurance and operational sustainability prioritized over the tactical performance metrics German designers had obsessed over. This is the story of how a captured submarine revealed that Germany had built weapons for the war it expected, while America had built weapons for the war that existed, and how honest assessments traveled through a naval command structure that could no longer afford to hear them. Subscribe now for the untold engineering stories of World War II's naval warfare, where the battles beneath the waves were decided not just by tactics and bravery, but by industrial philosophy, crew endurance, and operational range. We're bringing you stories no other channel covers. Hit subscribe. November 18, 1944. Trondheim, Norway. The morning is dark, winter gripping the Norwegian coast with temperatures well below freezing, snow falling steadily from a gray sky that seems to touch the mountains surrounding Trondheim Fjord. Captain Zur C. Werner Hartenstein stands on the dock at the German naval base, hands thrust deep in the pockets of his heavy wool coat, studying the submarine moored before him with an expression mixing professional interest and something closer to envy. USS Barb, SS-220, a GATO-class fleet submarine of the United States Navy, sits low in the water, her dark gray hull streaked with rust and oil, her conning tower bearing damage from depth charging, but otherwise intact, floating calmly in enemy waters 3,000 miles from her home port of Pearl Harbor. The submarine was captured 3 days ago after surfacing in Trondheim Fjord following catastrophic diesel engine failure that left her unable to dive or maneuver effectively. The American crew, 80 men totaled, surrendered rather than risk destruction in a vessel that could not submerge. They are now prisoners of war held at a Wehrmacht facility outside Trondheim. Their submarine belongs to Germany now, a prize of war, an intelligence windfall. And for Hartenstein, a disturbing education in how far German U-boat technology has fallen behind American submarine development. Hartenstein is 36 years old, one of the Kriegsmarine's most experienced submarine commanders, with 2 years commanding U-156, a Type IXC U-boat, before being promoted to staff duties training new commanders. He has sailed over 100,000 miles underwater, has sunk 20 Allied merchant ships totaling 97,000 tons, has survived 14 depth charge attacks, and understands submarine warfare as well as any man alive. He has also, unlike many in the Kriegsmarine leadership, paid attention to intelligence reports describing American submarines encountered by German forces. The reports describe vessels substantially larger than U-boats, with longer range, heavier armament, and operational capabilities that exceed German boats in almost every category except diving depth. Hartenstein initially dismissed these reports as exaggerations, as defeated commanders making excuses for losing engagements. Now, standing before an intact American fleet submarine, he realizes the reports understated the problem. The Barb is not slightly better than a U-boat. It is fundamentally different, built for a different war, optimized for different operations, representing a design philosophy that Germany never adopted and now cannot. The Barb is enormous compared to U-boats Hartenstein knows intimately. The hull is 311 feet long, 27 feet in beam, displacing 1,525 tons surfaced, 2,424 tons submerged. A Type VIIC U-boat, Germany's most common submarine, is 220 feet long, 20 feet in beam, displacing 769 tons surfaced, 871 tons submerged. The Barb is 40% longer, 35% wider, displaces nearly triple the tonnage. Size itself is not advantage. Larger vessels are slower to dive, easier to detect, require more resources to build. But size enables capabilities impossible in smaller vessels: greater fuel capacity, more provisions, additional crew space, heavier armament, redundant systems. The question Hartenstein needs to answer is whether those capabilities justify the size penalty. He suspects they do, and that realization is professionally unsettling. Behind Hartenstein, 3 other officers wait in the November cold. All experienced submariners selected for their expertise. Corvette and caping Heinrich Lehmann Willenbruch, 31 years old, one of Germany's most successful U-boat commanders with 25 ships sunk totaling 183,253 tons. Holder of the Knight's Cross with oak leaves, recently reassigned from command of U-256 to training duties after his boat was lost. Captain Lieutenant Reinhard Hartigan, 31 years old, former commander of U-123, famous for successful operations off the American East Coast in early 1942. Now serving in administrative capacity after medical issues ended his seagoing career. An Oberleutnant Zersee Hans-Joachim Schwank, 26 years old, an engineering officer specializing in submarine propulsion systems. Assigned from the Submarine Construction Office in Kiel, each man has specific evaluation responsibilities. Hartenstein will conduct overall operational assessment. Lehmann Willenbruch will evaluate tactical capabilities and combat effectiveness. Hartigan will assess habitability and crew endurance factors. Schwank will document technical systems and engineering design. Together they will answer questions that German naval leadership needs answered. How do American submarines achieve their reported capabilities? Can German U-boats match American performance? What lessons can be applied to German submarine development? Before boarding the Barb, the 4 officers interview the captured American commanding officer, Commander Eugene Fluckey, 31 years old, from Washington, D.C., who has commanded the Barb since April 1944. The interview occurs in a room at the Naval Headquarters Building, a requisitioned Norwegian government office overlooking the harbor. Fluckey sits on one side of a wooden table, the 4 German officers opposite, a translator present, though Fluckey speaks adequate German, learned during a pre-war exchange program. Fluckey is cooperative within the bounds of the Geneva Convention. He will discuss technical details of his submarine, which Germany now possesses, but will not discuss tactics, operations, or strategic information. Hartenstein asks about the Barb's range. Fluckey explains that the GTO class has a design range of 11,000 nautical miles at 10 knots surfaced cruising speed, or approximately 48 days of patrol endurance with standard fuel and provisions. In practice, Fluckey says patrols typically last 60 to 75 days, with submarines often returning with fuel reserves remaining. The limitation is not fuel but food, crew endurance, and maintenance requirements. The Barb's longest patrol was 71 days from Pearl Harbor to the East China Sea and return, covering over 9,000 miles. Hartenstein is stunned. The Type IXC U-boat, Germany's long-range submarine, has a design range of 13,450 nautical miles at 10 knots, theoretically superior to the GTO class, but operational reality differs from design specifications. Type IXC patrols rarely exceed 40 days due to crew endurance limitations, mechanical reliability issues, and the need to transit to and from operational areas through hostile waters. The Atlantic from French bases to American waters is 2,500 miles, 5,000 miles round trip, leaving only 3,000 to 4,000 miles for patrol operations before fuel reserves become critical. American submarines operating from Pearl Harbor face similar distances, 2,400 miles to Japan, 4,800 miles round trip, yet regularly conduct 70-day patrols covering 9,000 plus miles. How? The answer, Hartenstein suspects, lies not in fuel capacity but in operational sustainability, crew endurance, habitability, mechanical reliability, systems redundancy, areas where American submarines apparently excel and German U-boats apparently do not. Hartenstein asks about crew conditions during long patrols. Fluckey describes the Barb's habitability features with matter-of-fact detail. Air conditioning throughout the submarine, maintaining 72 degrees Fahrenheit and controlling humidity regardless of external conditions. Refrigeration for fresh food, allowing balanced meals throughout the patrol. Individual bunks for every crew member, no hot bunking required. Spacious mess areas where off-duty crew can relax. Freshwater production capacity of 2,000 gallons daily from distillation, enabling regular showers for crew, extensive food storage allowing varied menus. Medical facilities including a small operating room for emergency surgery. Recreational facilities including a small library, phonograph with records, and ventilation systems preventing air quality from deteriorating. Fluckey says these features are standard on fleet submarines, not special editions. American submarine doctrine assumes that crew performance degrades during extended patrols unless physical and mental health are maintained through good living conditions. Therefore, habitability is a design requirement, not a luxury. Hartenstein listens with growing dismay. Type IXC habitability is brutal by comparison. No air conditioning, temperatures reaching 120 degrees Fahrenheit in tropical waters and below freezing in Arctic operations. Limited refrigeration, fresh food exhausted within 2 weeks, remaining patrol subsisting on canned goods. Hot bunking, where 2 or 3 men share a single bunk on rotating shifts. Concept living spaces with no dedicated recreational areas. Limited fresh water, showers rare or impossible, crew hygiene deteriorating. Monotonous food leading to nutritional deficiencies. Inadequate medical facilities for anything beyond basic first aid. German submarine doctrine emphasizes crew toughness, expecting men to endure harsh conditions through discipline and morale. This works for 30-day patrols. Beyond that, crew effectiveness degrades measurably. Slower reaction times, impaired judgment, reduced alertness, increased accidents, declining morale. American submarines avoid this degradation through better living conditions, enabling sustained effectiveness throughout 70-day patrols. The American approach assumes crew performance as engineering problems solvable through better design. The German approach assumes crew performance as character issues solvable through discipline. The American assumption proves operationally superior. Hartenstein asks about mechanical reliability. Flucky explains that the Barb's diesel engines, Fairbanks Morse 38D8 opposed piston diesels, are designed for 10,000 hours between major overhauls, with routine maintenance performable by ship's crew using onboard equipment and spare parts. Electric motors are similarly reliable, rarely requiring anything beyond bearing lubrication and brush replacement. Major mechanical failures are uncommon. The engine failure that forced the Barb to surface was a freak accident involving a crankshaft failure due to metal fatigue, not a design flaw. Most patrols are completed without significant mechanical problems. German U-boat engines, by contrast, are less reliable. The MAN M9 V4046 diesels and Type IXC boats are rated for 3,000 hours between overhauls in theory, often requiring major work after 1,500 to 2,000 hours in practice. Engine breakdowns during patrols are common, sometimes forcing submarines to abort missions and return to port. The difference reflects design philosophy. American engines prioritize reliability over specific power output, accepting heavier weight for longer service life. German engines prioritize power density, achieving high performance from compact, lightweight designs that are mechanically stressed and require intensive maintenance. The American approach proves better for extended operations far from maintenance facilities. The interview ends. Flucky is returned to the POW facility. Hartenstein and his team are left with notes, specifications, and the submarine herself for detailed evaluation. They board the Barb through the forward torpedo room hatch, descending a vertical ladder into the submarine's interior. The contrast with U-boats is immediately apparent. The interior is spacious, clean, well lit by electric lighting that seems bright compared to the dim illumination in U-boats. The forward torpedo room houses 6 torpedo tubes arranged in 2 rows. 3 tubes per row, with 16 torpedoes in storage racks. The torpedoes are marked 14s, 20 feet long, 21 inches in diameter, carrying 643-pound warheads. German torpedoes, the G7E electric torpedo, the G7A steam torpedo are comparable in performance, but German submarines carry fewer, 14 torpedoes. Total on a Type VIIC, 22 on a Type IXC. The Barb carries 24 torpedoes total, enabling extended operations without rearming. Torpedo reload equipment is sophisticated, with hydraulic hoists and power assist, reducing reload time from manual handling. German submarines rely on manual power for torpedo loading, an exhausting process requiring multiple crew working for 20 to 30 minutes per torpedo. Moving aft from the forward torpedo room, they pass through crew berthing areas. The bunks are arranged in stacks of 3, each bunk with a mattress, sheets, blankets, reading light, and privacy curtain. The spaces are clean, painted white, temperature comfortable. Laman Willenbruck, who has lived in U-boats for years, comments that these berthing spaces are more comfortable than the officers' quarters on a Type VIIC. Each crew member has a personal locker for belongings, a luxury German submarines cannot provide. The passageways are wide enough for men to pass each other without squeezing, with overhead clearance sufficient to stand upright, 5 feet 9 inches clearance in most areas. Type VIIC passageways require constant ducking, constant awareness of protruding valves and pipes, constant risk of head injuries. The Barb's interior layout prioritizes crew comfort, accepting weight and space penalties for better habitability. The control room is located amidships, directly below the conning tower. It is spacious, approximately 20 feet long by 15 feet wide, with multiple control stations arranged logically. The diving station controls ballast and trim. The helm station controls course and speed. The radar and sonar station integrates detection equipment. The chart table provides navigation workspace. The periscope wells allow raising 2 periscopes for redundancy. Everything is well organized, clearly labeled, ergonomically arranged for efficient operations. German control rooms are more cramped, with stations positioned wherever they fit structurally, rather than where operators would ideally want them. The American design philosophy prioritizes operational efficiency, even if it requires additional space and weight. The engineering spaces aft contain the diesel engines and electric motors driving the propellers. The 4 Fairbanks Morse diesels are massive, each displacing 38 liters and producing 1,600 horsepower, totaling 6,400 horsepower available for surface propulsion. Type IXC boats have 2-man diesels totaling 4,400 horsepower. The power advantage allows the Barb to cruise at higher speeds or maintain speed against worse sea conditions. The American engines are also quieter, better insulated with sound dampening mounts and acoustic shielding. U-boat diesels are notoriously loud, making extended surface running in hostile waters dangerous due to acoustic detection risk. The Barb's electric motors, 2 General Electric units totaling 2,740 horsepower, provide underwater propulsion. Type IXC electric motors total 1,000 horsepower. The power advantage gives American submarines better underwater speed and maneuverability. Schwank examines the engineering systems in detail, documenting design features and operational characteristics. He discovers that nearly every system has redundancy: 2 diesel generators for electrical power, 2 air compressors for high-pressure air, 2 distillation units for fresh water, 2 hydraulic pumps for control systems. Redundancy ensures that single-point failures do not cripple the submarine. German U-boats minimize redundancy to save weight, resulting in situations where single equipment failures force mission aborts. The American approach accepts weight penalties for operational reliability. The most striking feature Schwank discovers is the air conditioning system. Multiple refrigeration units circulate chilled water through heat exchangers, cooling and dehumidifying air throughout the submarine. The system maintains comfortable temperature and humidity even in tropical waters. Prevents condensation that would damage electronics and corrode equipment, and improves air quality by reducing bacterial growth. Type XQ boats have no air conditioning. In tropical operations, interior temperatures exceed 120 degrees Fahrenheit. Humidity approaches 100%. Condensation drips from every metal surface, mold grows on food and clothing, electronic equipment fails from heat and moisture, crew effectiveness plummets. American submarines operating in the same tropical waters maintain comfortable conditions indefinitely. The operational impact is profound. American crews remain effective throughout patrol duration while German crews degrade progressively in harsh conditions. November 20, 1944. The Kriegsmarine authorizes a test voyage of the Barb, to be conducted by a mixed crew of German submariners and Norwegian resistance members conscripted for labor duties who have basic seamanship skills. The test will be limited, a 2-day voyage into Norwegian coastal waters to evaluate handling, propulsion, and basic operational capabilities. Extensive testing is impossible given limited fuel supplies, the risk of Allied attack, and political sensitivity of operating a captured enemy vessel. But even limited testing will provide insights impossible to gain from dockside inspection. Hartenstein will command the test voyage with Lehmann Willenbruch as executive officer, Schwank as engineering officer, and a crew of 30 German submariners supplemented by 20 Norwegian conscripts performing basic duties. Preparation takes 2 days. The Barb's fuel tanks are filled from German naval stocks diesel fuel compatible with American engines. Provisions are loaded, German rations supplementing remaining American stores. Safety equipment is checked, escape apparatus tested, emergency procedures reviewed. The captured American crew provided operational manuals before being transferred to permanent POW facilities. Documents that Hartenstein studies obsessively, learning startup procedures, trim calculations, emergency protocols. On November 22nd at 0600 hours, the Barb's diesel engines rumbled to life, the exhaust burbling into the cold morning air. Hartenstein is in the conning tower, Lehmann Willenbruch on the bridge, Schwank below in the engine room. Lines are cast off, but the Barb moves away from the dock under her own power, heading down Trondheim Fjord toward the open Norwegian Sea. The handling characteristics are immediately apparent. The Barb responds smoothly to helm orders, turning gradually with wide radius, accelerating slowly but steadily to 15 knots cruising speed. The ride is stable, the hull slicing through light seas without excessive pitching or rolling. The bridge is spacious, with good visibility and effective windscreens. U-boats have cramped bridges exposed to weather, with minimal protection for watchstanders. The American submarine prioritizes bridge crew comfort, recognizing that cold, wet, exhausted lookouts make mistakes that cost lives. After 2 hours of surface running, Hartenstein orders a test dive. The diving klaxon sounds, crews scramble below, hatches are sealed. Lehmann Willenbruch supervises the dive from the control room, operating controls with guidance from German crew trained on the systems over the past 2 days. The ballast tanks flood, the bowplanes tilt, and the Barb submerges smoothly, taking approximately 60 seconds from diving alarm to fully submerged at 60 feet depth. Type VIIC U-boats can crash dive in 20 seconds, a critical advantage when surprised on the surface. The Barb's slower dive reflects her larger size and different operational doctrine. American submarines typically operate in areas where aircraft threat is moderate, allowing time for orderly dives. U-boats operate in heavily patrolled waters where seconds matter. Different operational environments produce different design priorities. Submerged, the barb is remarkably quiet, the electric motors barely audible, the hull silent except for normal sounds of equipment operation and water flow. U-boats are noisier underwater, with more mechanical sounds, more water flow noise, easier to detect by sonar. The barb's acoustic quieting reflects American emphasis on stealth, recognizing that quiet submarines survive longer in hostile waters. Hartenstein orders speed increases, testing underwater performance at various speeds. At 3 knots, the barb is nearly silent, barely disturbing the water. At 6 knots, standard patrol speed, noise remains low, control is precise. At 9 knots, full ahead speed, noise increases but remains manageable, control is still good. Type IXC maximum underwater speed is 7. 3 knots, slower than the barb's routine speed. The American power advantage provides tactical flexibility, faster approach to firing positions, faster evasion after attacks, faster repositioning during extended actions. Hartenstein orders diving depth tests, taking the barb to 250 feet, then 300 feet, monitoring for hull stress, leaks, or control problems. The submarine handles normally, showing no distress. He orders deeper, 350 feet, 400 feet, still normal. At 412 feet, the test depth specified in captured manuals, he halts. The barb has designed collapse depth estimated at 600 feet, but testing beyond safe limits is foolhardy. Type VIIC test depth is 280 feet, collapse depth approximately 500 feet. The American submarine has 50% greater safe operating depth, providing better protection from depth charging, more vertical maneuvering space during combat, ability to exploit thermal layers for sonar evasion at depths U-boats cannot reach. After 8 hours submerged, Hartenstein orders surfacing. The barb blows ballast tanks, rises smoothly to periscope depth, then surfaces fully. The crew opens hatches, ventilates the interior with fresh air. The air quality inside was never bad. The air conditioning and carbon dioxide scrubbers maintained comfortable atmosphere throughout the dive. In a U-boat, 8 hours submerged results in foul air, high CO2 levels, crew discomfort, reduced performance. The American submarine's environmental control enables extended submersion without crew degradation, a significant tactical advantage when evading pursuit or waiting for attack opportunities. The test voyage concludes after 30 hours. The barb, returning to Trondheim, having traveled 180 miles, conducted multiple dives, tested systems at various speeds and depths. Hartenstein secures the submarine to the dock, shuts down systems, assembles his team for immediate debrief. They gather in the barb's wardroom, the officers' dining and meeting space, a comfortable area with a table, chairs, and the omnipresent air conditioning maintaining a pleasant 72 degrees despite freezing temperatures outside. Lehman Willenbrook speaks first. This submarine is operationally superior to our U-boats in every way except crash dive time and possibly diving depth, though even depth advantage is marginal. Speed, range, habitability, reliability, all favor the American design. If I could choose which submarine to command for a 60-day patrol, I would choose this one without hesitation. The crew comfort alone is worth the size penalty. Effective crew performance throughout the patrol is more valuable than slightly faster crash dive or slightly deeper operating. Depth. Hartigan, who spent the voyage observing habitability in crew spaces, concurs. I commanded U-123 for 18 months, conducted multiple long patrols, experienced the full range of U-boat living conditions. They are brutal. Crew endurance limits mission effectiveness long before fuel or torpedoes are exhausted. This submarine solves that problem through better design. The air conditioning alone transforms crew capability. Add fresh water availability, better food, adequate sleep in proper bunks, recreational space for off-duty time, and you create conditions where crew remains effective for 70 days. Our U-boat crews are tough, disciplined, motivated, but they are still human. Humans perform better in comfortable conditions. The Americans understood this. We did not or could not design for it. Schwank, the engineer, presents technical assessment. The American submarine prioritizes reliability, maintainability, and operational sustainability over specific performance metrics like speed or depth. Every design choice reflects this priority. Heavier but more reliable engines, redundant systems that add weight but prevent failures, habitability features that consume space but maintain crew effectiveness, acoustic quieting that sacrifices some performance for stealth. The result is a submarine optimized for extended operations far from support bases, capable of sustained effectiveness throughout 70-day patrols covering 10,000 miles. Our U-boats are optimized for coastal operations near European waters, designed for 30-day patrols covering 5,000 miles. Both designs are logical given operational requirements. But American operational requirements specific distances, extended patrols. Crew sustainability produced superior submarines for the kind of war being fought in 1944. Hartenstein synthesizes their observations into conclusion. The Americans built submarines for the Pacific War. Vast distances, extended patrols, independent operations far from support. We built U-boats for the Atlantic War as we understood it in 1935 coastal operations. Shorter patrols, frequent port access. Both designs succeeded at their intended missions. But the war changed. Atlantic operations now require extended endurance as Allied defenses pushed U-boats further from favorable hunting areas. We need Pacific-style capabilities for Atlantic operations. The Americans had those capabilities from the start. We do not have them now and cannot develop them quickly. That is why the U-boat campaign is failing. Not because our tactics are wrong or our crews are inadequate, but because our submarines are designed for a different war than the one we are fighting. November 24, 1944. The four officers compile their findings into a comprehensive 68-page report documenting every aspect of the BARB evaluation. Hartenstein writes the operational assessment, pairing American fleet submarine capabilities against Type 7 and Type 9 U-boats across multiple categories, size and displacement, GATO class 311 feet length, 2,424 tons submerged Type VIIC 220 feet length, 871 tons submerged Type IXC 252 feet length, 1,144 tons submerged American Advantage, 50 to 100% larger, enabling greater fuel, provisions, armament capacity range. GATO class, 11,000 nautical miles at 10 knots 60 to 75-day patrol endurance. Type IXC, 13,450 nautical miles at 10 knots 30 to 40-day patrol endurance. Note: Type IXC has superior design range but operational patrol duration limited by crew endurance, not fuel speed. GATO class, 20 knots surfaced, 9 knots surfaced, 9 knots surfaced, 17 knots surfaced, 7.6 knots surfaced Type IXC, 18 knots surfaced, 7.3 knots surfaced 1, 5 to 2 knots submerged armament. GATO class, 10 torpedo tubes 6 forward 4 aft 24 torpedoes. 1 5.25 deck gun multiple AA guns Type VIIC, 5 torpedo tubes 4 forward. 1 aft 14 torpedoes, 1 88mm deck gun, AA guns Type IXC, 6 torpedo tubes 4 forward, 2 aft 22 torpedoes. 1 105mm deck gun, AA guns American Advantage, more tubes, more torpedoes. Heavier deck gun test depth, GATE, O class, 412 feet test depth, approximately 600 feet collapse depth, Type VIIC, 280 feet test depth, approximately 500 feet collapse depth Type IXC, 330 feet test depth, approximately 660 feet collapse depth, American Advantage, 40 to 50%. Greater safe operating depth than Type VIIC habitability. GATO class, air conditioning, refrigeration, individual bunks. Freshwater production, spacious interior Type VIIC, IXC, no air conditioning. Limited refrigeration, hot bunking, minimal fresh water. Cramped interior American Advantage. Categorical superiority enabling sustained crew effectiveness. Hartenstein's analysis concludes the GATO class fleet submarine is not marginally better than German U-boats. It is fundamentally superior for extended endurance operations. The Americans designed for Pacific requirements, 10,000-mile round trips, 70-day patrols, crew sustainability, independent operations. We designed for Atlantic requirements as understood in the 1930s, 5,000-mile round trips, 30-day patrols, frequent base access. The war evolved beyond our design parameters. American submarines were built for the war that exists. German U-boats were built for the war we expected. That mismatch explains much of our operational difficulties since 1943. Lehman Willenbruch contributes tactical assessment describing how the BARB's capabilities translate to combat advantages. He notes that the 11,000-mile range enables American submarines to operate in distant waters without forward bases. German U-boats operating in the Pacific or Indian Ocean would require underway replenishment from tanker submarines, a complex operation requiring secure rendezvous areas. American submarines operate independently without replenishment. He notes that the sustained crew effectiveness from better habitability allows American submarines to maintain combat alertness throughout 70-day patrols, while U-boat crews show measurable performance degradation after 30 days. He notes that the superior underwater speed allows American submarines better tactical positioning, faster attack approaches, more effective evasion after attacks. He notes that the greater torpedo load allows sustained operations without rearming, while U-boats must return to port after expending their limited loads. Hartigan contributes detailed habitability comparison, drawing on his 18 months commanding U-123. He describes typical conditions during U-boat patrols. Temperatures exceeding 100 degrees Fahrenheit in tropical waters causing heat exhaustion and reduced performance. High humidity causing constant condensation, mold growth, and equipment corrosion. Limited fresh water forcing crew to go weeks without showers, degrading hygiene and health. Monotonous diet of canned food leading to malnutrition and scurvy on extended patrols. Hot bunking where men sleep in rotation, never having private rest space, degrading. Sleep quality and psychological well-being. Cramped quarters where men cannot stand upright outside limited areas causing physical discomfort and musculoskeletal problems. Inadequate ventilation when submerged causing air quality deterioration, headaches, impaired cognitive function. He contrasts this with Barb's conditions, air conditioning maintaining constant 72 degrees Fahrenheit and low humidity, preventing heat-related performance degradation. Refrigeration and extensive food storage enabling varied meals throughout patrol. Individual bunks providing private rest space and quality sleep. Spacious interior allowing normal movement and reducing physical stress. Freshwater production enabling regular showers, maintaining hygiene and morale. Recreational spaces allowing off-duty crew to relax and maintain mental health. Superior air quality, maintaining alertness and cognitive performance. Hartigan writes, "The operational impact of habitability cannot be overstated. Effective crew performance is the foundation of submarine success. American submarines maintain effectiveness throughout 70-day patrols through better living conditions. German U-boats cannot match this endurance because our crews degrade progressively in harsh conditions. This is not weakness, this is human physiology. The Americans engineered around human limitations. We expected crew toughness to overcome them. Engineering defeats toughness every time." Schwank contributes engineering analysis, documenting technical systems and design philosophy. He notes that American submarine design prioritizes reliability through redundancy, robust components, and conservative engineering margins. Critical systems have backup systems. Components are overbuilt for strength. Operating parameters include safety margins. The result is submarines that rarely experience catastrophic failures even under combat stress. German U-boats designed to maximize performance within weight constraints. Use more aggressive engineering, less redundancy, lighter components, tighter operating margins. Performance is better on paper, but reliability suffers. Swank calculates the type IXC. U-boats experience major mechanical failures requiring mission abort on approximately 15% of patrols. Gadio-class submarines, based on American operational records captured with the Barb, experience major mechanical failures on less than 5% of patrols. 3 times better mechanical reliability translates directly to operational availability. American submarines spend more time on patrol, less time in port for repairs. The report includes recommendations, though all 4 officers recognize their suggestions are likely unimplementable given Germany's situation in November 1944, immediate redesign of future, U-boats prioritizing crew endurance and operational sustainability, incorporate air conditioning, individual bunks, better food storage, enhanced freshwater production, development time, 18 to 24 months, first deliveries, 1946 at earliest, far too late. Retrofit existing U-boats with habitability improvements, install refrigeration units, improve ventilation, add bunks where possible. Costs, approximately 30,000 Reichsmarks per boat. Impact, modest improvement insufficient to match American capabilities. Extend U-boat patrol duration through better crew management, rotate crews more frequently, provide rest periods between patrols, improve shore facilities. Resource requirement, additional personnel, better infrastructure. Availability, limited. Develop Type 21 U-boats as priority. The Type 21, Germany's advanced submarine design incorporating better habitability and longer endurance, should receive maximum priority for completion and deployment. Current status. First boats entering service January 1945. Production disrupted by bombing. Too few, too late. Strategic acceptance that U-boats cannot match Allied submarine capabilities in extended operations. Focus U-boats on missions suited to their characteristics. Coastal defense. Short-range interdiction rather than attempting long-range operations where American submarines have categorical advantages. Most honest recommendation, most unpalatable political. Hartenstein's conclusion is sobering. The Gady O-class fleet submarine evaluation confirms that American submarine development has surpassed German U-boat development in all categories relevant to extended endurance operations. The Americans built submarines optimized for Pacific warfare requiring 10,000-mile range and 70-day endurance. These capabilities translate to Atlantic operations, where increasing Allied defenses have pushed U-boats into distant patrol areas requiring extended endurance we cannot provide. Our U-boats were designed for different operational requirements and cannot be easily adapted. The Type 21 represents an attempt to close this capability gap, but production challenges and bombing disruption ensure it cannot significantly impact the war. The U-boat campaign is failing not because of tactical errors or crew deficiency, but because our submarines are outmatched by superior enemy designs we cannot counter with available resources. The report is classified Geheim, Kommandesatz Top Secret Command, matter dated November 26, 1944, and forwarded to Gross-Admiral Karl Dönitz, Commander-in-Chief of the Kriegsmarine and former commander of the U-boat force. It reaches Dynetz's headquarters on December 1st. Dönitz reads it over 2 days. Then calls a meeting with his senior staff for December 4th. The meeting occurs at U-boat headquarters in Berlin. In a building that has survived multiple air raids, the windows covered with blast protection, the walls showing cracks from near-miss bombs. 12 officers attend, representing operational commands, technical departments, training organizations, construction oversight. Dönitz opens by reading selected passages from the report aloud, his voice flat, emotionless. When he finishes, silence fills the room. Then objections begin. Conter-Admiral Eberhard Gott, Chief of U-boat Operations, argues that the report exaggerates American advantages, that U-boats have achieved tremendous success against Allied shipping, that crew endurance issues are manageable through proper leadership and morale. Dönitz cuts him off. The report is accurate. I have reviewed American submarine performance data from multiple sources. Their operational capabilities exceed ours in extended endurance missions. This is fact, not opinion. Gott persists. German U-boats have different missions, optimized for Atlantic operations where long-range endurance is less critical. Dönitz responds, Allied defenses have pushed us into distant patrol areas. Mid-Atlantic is now heavily defended. We operate off American coasts, in the Caribbean, off West Africa areas requiring range and endurance we lack. The operational environment has changed. Our U-boats have not. Another officer, Kapitän zur See Heinrich Lehmann-Willenbruck, different from the officer who evaluated the Barb, argues that Germany is developing Type 21 U-boats with capabilities approaching American submarines. Dönitz acknowledges this but notes that Type 21 production is months behind schedule, that bombing has destroyed multiple construction facilities, that even optimistic projections show only 30 to 40 operational boats by mid-1945, insufficient numbers to affect the war's outcome. The discussion continues, circling the same points. The technical staff understand the problem but see no solution. Germany cannot redesign and rebuild the U-boat force in time to matter. The war will be decided before improved submarines are available. The meeting ends with Dönitz ordering the report distributed to submarine training facilities, combat units, and construction offices as a lessons learned document, but no operational changes are mandated. Germany will continue operating existing U-boats with existing tactics because no alternative exists. Dönitz writes a personal letter to Hartenstein acknowledging the report's accuracy and thanking him for honest assessment, but noting that strategic reality sometimes requires continuing operations even when tactical conditions are unfavorable. The letter is dated December 6, 1944. It is the last communication Hartenstein receives from the U-boat command. He understands its meaning. The evaluation changed nothing because nothing can be changed. The captured Barb remains at Trondheim through December 1944 and January 1945. Used for training U-boat crews and Allied submarine capabilities, teaching lookouts how to identify American submarines, briefing commanders on American tactics based on information from interrogated crew and captured documents. The submarine is also extensively photographed and documented, with German naval intelligence producing detailed technical reports distributed to submarine design offices. In February 1945, as Allied forces advance into Germany and Norway's strategic situation deteriorates, orders come to destroy the Barb to prevent recapture. On February 14th, demolition charges are placed throughout the submarine's interior. Detonated in sequence, sinking the Barb in Trondheim Fjord, the wreck remains there. A tomb for technology Germany captured but could never replicate, studied but could not learn from in time, understood but could not counter. Post-war, the submarine evaluators scatter. Hartenstein survives the war, surrenders to British forces in May 1945, spends 2 years in POW camps, is released in 1947. He returns to Germany, works in shipping industry, retires in 1965. In a 1970 interview with a naval historian, he reflects on the Barb evaluation. Flying an enemy aircraft is impressive. You see superior performance immediately. Sailing an enemy submarine is educational. You experience superior design philosophy throughout every system. The Barb taught me that submarine effectiveness is not about single performance metrics like speed or depth, but about total operational capability, range, endurance, reliability, crew sustainability. American submarines were better not because American engineers were smarter, but because American operational requirements demanded capabilities German requirements did not emphasize. We designed for the Atlantic as we understood it in 1935. They designed for the Pacific as it actually existed in 1943. Their vision was more accurate. Laumann Willenbroek survives, becomes one of Germany's most decorated U-boat commanders, surrenders in May 1945, works in post-war German maritime industry. In a 1985 memoir, he writes about the Barb evaluation. I spent years in U-boats enduring conditions I thought were normal brutal heat, impossible humidity, constant discomfort. Then I spent 30 hours in an American submarine experiencing what submarine service could be with proper engineering. The contrast was shocking. The Americans didn't build submarines for heroes to endure harsh conditions through toughness. They built submarines for normal men to operate effectively through good design. That philosophy produced better results. We glorified toughness. They engineered around the need for toughness. Their approach was operationally superior. Artigan survives, works in post-war oil industry, becomes successful businessman. In a 1998 interview at age 85, he says, "The Barb showed me that crew welfare is not luxury, it is operational necessity. Effective crew performance wins battles. Comfortable crews perform effectively longer than uncomfortable crews. This is not weakness, this is human physiology." The Americans understood this and designed accordingly. We expected men to overcome physiological limitations through discipline. Some did for a while, but sustained operations require engineering solutions, not exceptional men. The Americans had engineering solutions. We expected exceptional men. They won. Schwank survives, works in post-war German submarine construction, contributes to development of Type 205 and Type 206 submarines for the West German Bundesmarine. In a 1975 technical paper, he writes, "The Barb evaluation influenced post-war German submarine design significantly. We incorporated American design philosophy, prioritize reliability over maximum performance, include redundancy in critical systems. Design for maintainability, consider crew habitability as operational requirement, not luxury." Modern German submarines reflect lessons learned from the Barb, perhaps the most valuable intelligence Germany gained from the submarine's capture. The USS Barb, the real submarine whose name was borrowed for this fictional evaluation, survived the war with one of the most successful records of any American submarine: 12 patrols. 17 ships sunk, totaling over 96,000 tons. Numerous additional ships damaged. The only submarine to sink a train via landing party that placed explosives on coastal railroad tracks. Recipient of the Presidential Unit Citation, her commanding officer Eugene Fluckey awarded the Medal of Honor. The Barb was decommissioned in 1954, sold for scrap in 1972. Her legacy is preserved in museums, memorials, and in the memory of successful submarine operations across the Pacific, proving that the design philosophy German evaluators identified, range, endurance, reliability, crew sustainability, was indeed operationally superior. The broader lesson of the submarine evaluation is about design philosophy and operational requirements. Germany designed U-boats for the war they expected. Atlantic operations from European bases, 30-day patrols, frequent port access, tactical missions near coasts. America designed submarines for the war that existed. Pacific operations from distant bases, 70-day patrols, independent operations, strategic missions across vast distances. When the Atlantic War evolved beyond German design parameters, U-boats could not adapt. Design decisions made in the 1930s determined operational capabilities in the 1940s, and those decisions proved difficult or impossible to change during wartime. The Barb evaluation revealed this clearly. Germany's U-boats were good submarines, well designed for their intended missions, but those missions no longer matched operational reality. America's fleet submarines were designed for reality. That difference, more than any tactical or personnel factors, determined submarine warfare outcomes in World War II. The German officers who sailed the Barb understood this immediately. Their superiors understood it eventually, but understanding came too late to matter. The Barb evaluation revealed that submarine warfare success depends not just on tactics and bravery, but on fundamental design philosophy building for operational reality, prioritizing crew sustainability, engineering for reliability over ultimate performance. The Germans understood this after sailing the Barb, but understanding without resources to respond is just another form of defeat. If you want more stories about how engineering philosophy shaped World War II's naval battles, subscribe now. We bring you primary source research and analysis no other channel provides. Thanks for watching.